All right, so we've seen that the definite integral corresponds to area underneath the graph. So that means that if the function that we're given, if the f of x is a nice function, then sometimes we can just use geometry to figure out the exact value of the integral. Let's look at a few of these. This first one, we've got the integral from 0 to 4 of 4 minus x dx. So if we graph that, 4 minus x looks like this. And it crosses down here at 4, and it crosses up here at 4 as well. So we're trying to find this area inside of here. And we can do that easily since this is just a triangle. This is equal to, well, it's a triangle, so 1/2 base times height. And for this thing, the base and height are both 4. So this gives us 8. Now let's check that. There's not really any real need to, but I want to put it in here just for fun. Let's see, 4 minus x, and we're going from 0 to 4. Notice I've got this, let's see, z standard. All right, so notice it's given me 8.08. It's given a slight overcount with 100 rectangles. And the reason for the overcount is because if you zoom way in on this, yeah, it's counting a little bit of extra stuff there on the outside. But anyway, that sort of corroborates that our value of 8 is correct. All right, let's look at the next one, 2x plus 1. This one is it's only slightly more complicated. 2x plus 1, that's a line with a slope of 2 and a y-intercept of 1. So we're going from 1 to 4. So 1 and then 4. So we're looking at this area inside of here, which I'll color really quickly. So we're trying to find this area. Now, there's a couple of ways we can do this. First up, let's figure out the coordinates of these points. That point, it's x. This point here, it's x coordinates 1, so its y coordinate is going to be 3. And this point up here, its x coordinate is 4, so its y coordinate's 9. So if you know the formula for the area of a trapezoid, you can do that, but probably the more straightforward way of doing this is to, there are really two things this is the first thing that comes to my mind, is to split it up like this. And then we've got area 1 and area 2. So the integral here is equal to a1 plus a2. A1 is just a rectangle. Let's see, how wide is it? Well, it's 1 to 4 wide, so that's 3. And how tall is it? It's from 0 up to 3. So my drawing isn't great because that should be a square, but that's got an area of 9. Now A2, that is, its area is 1/2 base times height. The length of the base here is 3. And the height, well, to find the height, probably the easiest thing to do is, first note, this is the point 4, 3. How do I get that so quickly? It's got the same x coordinate as this point and the same y coordinate as this one. So the height of this thing is going to be 9 down to 3. So the height of the thing is 6. So if you multiply it out, 6 times 3 times 1/2 is 9. So this gives us 18 for our answer. All right. Now, another way you could do this, if you wanted, you could work it out like this. Draw this in here. You could continue this back over here. This is 4. This is 1. You could work out the area of these two triangles. You work out, here's the big triangle. You could take its area and then subtract out the area of this little triangle in here. So you could do that, and that would also give you the same thing. And there are probably some other sillier ways you could do it, but those are the two ways that popped to mind for me immediately. And this is what I think is the easiest. All right, this next example, there's actually a typo here. This is one that we can't really do using geometry, but that's because there's a typo in it. There's supposed to be a square root around this. So with the square root there, this is one we can do. So notice, if you take the function y equals square root of 9 minus x squared, that is a semicircle. It's the top half of a semicircle with the radius of 3. So we want to try to find the area inside of here. So the area of a semicircle is 1/2 pi r squared. And the radius of this thing is 3, so that gives me 9 pi over 2. All right, and that's the exact value. Let's compare that to what we get on the Riemann calculator. If I put this in, square root of 9 minus x squared, it gives me that. If I put in here to go from -3 to 3, and draw some rectangles, it gives me that. And what's it give me? 13.666. I just had a cat run through here very fast. Let's see, what is 9 pi over 2? 9 pi over 2. As a decimal, 9 pi over 2 is supposed to be 14.137, etc. And that down there is not too bad. If I put in a bunch of rectangles, say 1,000, 14.1369. If I change that to midpoint, it's giving me 14.137. This is giving me 14.137, and they start to differ in the 4th decimal place. So anyway, I don't know. I think it's fun to compare it to what that calculator gives us. But this is the exact answer here: 9 pi over 2. All right. Let's see. How many more examples do I have? 3 more examples. I will put these other examples in the next video.